Welcome everyone to my LeetCode Biweekly Contest 148 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be doing the contest live, answering questions and giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared during the contest, but immediately after it ends, we'll go through answers for all 4 questions. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright, I see a few people in chat already. Welcome. Hi, good to see a familiar face. Well, a familiar username. Start at 8 PM. Yeah, Shrivats. I normally come in just a few minutes before the contest. How's everybody doing this glorious evening, I guess? Evening or morning, depending on which part of the world you're from. Okay. Yeah, hopefully today's contest will be kind to all of us, not as difficult as the ones before. I feel like the contests have been getting harder and harder as time goes by. I think it's intentional that the contests are getting harder. I think it's because, like I've noticed that the contest sort of bifurcates. There are people who just solve everything right away, and then there are people, regular people who take much longer to solve. So LeetCode is sort of skewing its difficulty based on the people who solve it right away, the sort of power user, the small fraction of power users on the site. I think that's both good and bad. But I think at the end of the day, it depends on what people want to what people want to get out of the contest. I think people who just want to solve really, really difficult problems very quickly and get a very high contest ranking, then maybe that's what LeetCode is catering for. I don't know. Of course, I don't actually think that solving contests is the best way to learn and get better at programming, but you guys have all heard my spiel before. Okay. Hey, Red Finance. I have exams to study for. Oh, what exams are those? Well, good luck in your exams. Exams. It's January. Interesting. I didn't realize that people have exams in January. I thought it's normally the end of the semester in December. I'm hoping it's not too hard. Yeah, it has bit manipulation. Oh my god, the bit manipulation. Well, it depends on what language you're in. I feel like if you're in C, the bit manipulation is a bit easier. I guess that's not true because every language has these like bitwise operators, whether you're in C, you're in Java, or anything else. You haven't been able to solve today's daily? Okay. Oh, today's daily is quite hard. Some week of the month special harder contest. Yeah, I agree. You know what? You're making some really good points. I really agree with you. They should have some weeks where it's harder and some weeks it's easier. I think maybe make the bi-weekly harder and make the weekly easier. So this way people can sort of have the balance, right? But it is what it is. Let me see. So minimum cost to make at least one valid path. This one is hard. It's not super hard. It's I guess I can show my wait, where's my submission? Yeah, well, we can deal with that later. Yeah, it's not super hard. It's pretty standard problem if you do a lot of contests. Yeah, you use Python like me? Oh, thank you. That's really cool to see. Okay, the contest is about to start. Let me see. In 18 seconds. So good luck, everybody. Good luck, everybody. Reminder, I don't show code during the contest, so if you see that I'm not doing anything on screen, that doesn't mean I'm slacking off. It means I'm coding on a different screen. Ask questions in the chat and I'll come talk to you. All right, cool. Let's see what we got here. Maximum difference between adjacent elements in a circular array. Find the maximum absolute difference between adjacent elements. The first and last elements are adjacent. Okay, cool. So this one doesn't look too difficult. Wow, I see some 6 and 8 point questions later on. So the difficult ones are later. Man. But this one doesn't look too difficult. If you need help, once again, I don't show code. I don't show solutions while the contest is running. But immediately after it ends, we'll talk about it. So if you want solutions, sit tight. But I do recommend you try it out yourself while the contest is running. Okay. All right. Question 2. Minimum costs to make arrays identical. You're given two integer arrays R and BR of length n and an integer k. You can perform the following operations on R any number of times. You can split R into any number of contiguous subarrays and rearrange these subarrays in any order. So technically you can arrange the whole array. Okay, so technically you can arrange the whole array because, yeah, you can just like the subarrays, any number of contiguous subarrays can all be length 1. Choose any element in R and add or subtract a positive integer to it. The cost of this operation is x. Return the minimum cost to make R equals to BR. Okay, so a subarray is a contiguous non-empty sequence of elements within an array. Okay, so choose any element in R and add or subtract a positive. Okay, so if you add or subtract 1, then it sort of increases by 1. Okay, so basically what I'm saying is that I need to rearrange okay, I think Oh, hello there, Nubido. Welcome, welcome. I don't recognize your name. But welcome to the channel. Welcome to the stream. I think this is kind of like yeah, I think for this problem is kind of like sorting. You just sort them and then find out the minimum cost to turn one into the other. Because this one you only need to do once. You don't need to do this more than once. You only ever have to do this once. Since you can rearrange them, contiguous subarrays can be length 1. So you can rearrange them in any way you want. And so you only have to do this once. At most, I guess you only have to do this at least at most once. Okay, let me try it out. Yeah, let me read this more carefully. Okay, subtract 2. Okay, the cost of, okay. So this is like absolute value. Absolute difference. First plus abs of I. Okay. Yeah, I'm trying to do more questions this time, so I don't mind if I take a penalty. Okay. Yeah, I think that's correct. Hints for question 2. Think about how many times you need to use the first condition. Yeah. Yeah, exactly. If you, it's like a weird way of saying it, but you don't need to. You only need to use the first operation a very small number of times. So think about it. Question 3. You're given an undirected tree rooted at 0 with n nodes numbered 0 to n minus 1, represented by a 2D array edges of length n minus 1. Okay, so this is a tree. This is a tree. The edges are undirected. Is undirected. Okay, within UV with length. Okay, it's weight basically, not length. You're given an integer array nums where nums I represent the value and node I. Okay. A special path is a downward path from an ancestor to a descendant node such that the value of the nodes are unique. Note that path can start at end of the same node. Okay. Okay, the path doesn't have to go from ancestor to a descendant. It doesn't have to go from root to leaf. Return an array of size 2 where result 0 is the length of the longest special path. And length 1 is the minimum length number of nodes in all possible longer special paths. All longer special paths. Okay, let's look at example. So here's example 3. Okay. In the longer special path, what is it? Result 1 is the minimum number of nodes in all possible longer special paths. What? What's the minimum number of nodes in all possible longer special path? Is the minimum number of nodes is the length? Okay, so this one I don't quite get. So here's the longest path 0, 1. The longest special path is this one, right? 2, 5, 0, 1, 4, 0, 1, 4. Oh, I see. So the length is not the number of edges, it's the sum of the weights of the edges. I see. Gotcha. Okay, so this is longer special path 0, 1, 4, length of 6. The minimum number of nodes across all special paths is 2. And then 0, 1, 4 is 2, 5. 2, 5. Also 6 is also a long special path. So this is not the longest special path. I see. Gotcha. Okay, this makes sense. Okay, let me think about how to do this. So this is like a tree problem. Tree problem. Let me see another example first. Okay, so in this case, the only special path is this. This is the only special path. The length of the longest only special path is why is the length why is the length 0? Oh, the length is 0 because they are these two are both value 2. I see. So there's no special path here. There's no special path here. The smallest special path is length 0. There's no special path. Because the only path is from 0 to 1, and 0, 1 are the same value, same nums. Okay, I see. So the way to read this diagram is these nums are basically they determine the color. Oh, okay, so this is not a special path because these two are both red. So they're both value 2. So they're both red here. I see. Okay. So it looks like it looks like a tree problem, no? It looks like a tree problem. Two, 1, 1, 1, 1, 1, 1. Okay, this is the node, and then next to it is the sort of value, and then 3. And so what you want to do probably is to solve. You want to solve for each of these subtrees. You want to solve for a subtree. And when you solve for the subtree, you basically you solve for a subtree, you basically sort of push the answer upwards. Let me check the size. Okay, this is fairly big. So the number of nodes is fairly big. So I have to be a little bit more efficient about this. Let me read the chat real quick. So I can do 3 since I don't know trees very well. 2 is not difficult. 2 is not difficult. Don't overthink it. Don't overthink it. Yeah. Let me try number 3 first. I'll try the third one first. The fourth one looks really hard. It's at least the points is 8 points, so it's really hard. But for number 2, I would suggest don't overthink it. It's just really don't overthink it. It's the most intuitive solution turns out to be correct. Okay, I have to think a little bit about question 3. Yeah, I think you need some way of basically is let me see. Oh, this is also not a binary tree. This is just regular tree. So UV. Okay. By the way, if folks have questions about you need help with question 2 or 3, let me know. I haven't looked at question 4 yet, so I won't be able to help you there. Or ask in the chat. Somebody might be able to help you. I think we have a pretty robust chat today. It's good to see a lot of familiar faces in the chat as usual. Yeah. U V equals length. Okay, let me see. So the root of the tree is at node 0. Essentially, for each tree, I need to calculate. For each tree, I need to calculate what its longest path is. Can I calculate all the possible paths in the tree and then find what the longest ones are? I think that might work, but it might be too slow. So for instance, I'll calculate all the possible paths in this tree. That might be too slow though. That probably work, but it might be really, really slow. It seems really, really slow. Especially since the number of nodes is very large. Because the number of paths in the tree is kind of exponential. Imagine if the tree is just one line, straight line down, it's going to be n squared. Okay. So if I were to calculate this as a tree, let's see. For each node, I'm gonna need for each node I'm gonna need yeah, I think it kind of looks inevitable. Kind of looks inevitable. I think I'll have to calculate all the paths. Yeah, it kind of looks inevitable. So what I need is best, longest, and the minimum. Let me take a look at chat. Nobito, I'm doing question 2 and I think it has some level of sorting involved. Yes, that's correct. Some level of sorting. Bro, I gave out the contest already. Like literally 4K accepted within 10 minutes on 2 questions. Yeah. You know what? I feel like many are cheating, but many of the people are pretty legit. You know, some of them are pretty legit. Yeah. Also, I think Nobito is right. You know, they cheat. They can cheat all they want. It doesn't affect you. You just want to get better at programming. So, as long as you're learning something, that's all that matters. There's no prize for placing first in the contest. It's not like they give you a medal. Okay, so if I try to find all the unique. Yeah, I think it's some kind of backtracking. I think so. I think question 3 is some kind of backtracking. Yeah, I don't know whether I can do better than that. Okay, I'm gonna try that. Well, Nobito, you just have to try it. Just submit and then see how it works. It's a little bit risky, but if it fails, the most you'll lose is 5 minutes. So I just try. I honestly I've lost a lot of 5 minutes. I've taken a lot of penalties. Yeah, but don't overthink it. I think you're on the right track. I'm s- hmm. Ah man, I really don't want to get stuck in question 3. Damn it. So 0, 2, uh 2, 5, 5, 11. No. So it's 2, 0. Again, 1, 2, 2, 5. And then 1, 11. Okay. Sorry if I'm quiet. I'm thinking about question 3. Okay, let me read the chat a little bit. Main, if erase dot equals return. Yep. Yeah. Well, Nobito, I think you should try it out. Yeah. Well, let me go through question 2 a little bit, since there is a demand for it. Which one is question 2? Okay. All right. I don't want to give away the game, but the main thing to look at is this. Split R into any number of contiguous arrays, and then rearrange them in any order. Okay? What's the best way to use this? Well, technically, you can just split R. You don't have to split into like this and this, right? You can just split into individual numbers. You can split them into individual numbers and rearrange them in any way you want. So basically, this operation, you only need to do once. You only ever have to do this once. And the idea is either you do it 0 times or you do it 1 time. You do it 1 time, what's the best way to rearrange R so that it minimizes the difference from Burr? So think about what's the best way to do this. Yeah, some of you are on the right track. My suggestion is try it out. Your intuition is probably correct. I won't give away any more than that. But yeah, your intuition is probably correct. So trust yourself. Try it out. If it doesn't work, then at the most you'll lose is 5 minutes. Length. If length. first example. I can think of cases where it won't work. Greedy work for question 2. Try it out. Just try it out. Yeah. So Sujit Patel passed 519 test cases. I'm not getting first example itself. Wait, what question are you talking about? Yeah. Welcome to the chat, by the way. So Suji Patel, I don't think I recognize your name. Oh, second one? Yeah, I strongly believe this is a bug in your code. Check if there's a bug. So you can there are two cases, either you sort them or you don't sort them. So check if you're missing something. You remember when you sort them, it costs an extra K. So make sure all those little things are there. It sounds like your code is your sort of strategy should be overall correct. But it's just some small execution that's tripping you up. Okay. I am still working on question 3. That's why I'm been a little bit quiet. But let me look at chat to make sure there's people here. Second one, okay. Geeky Rich. Alex, buddy, I'm in the most urgent need of my life. Okay. Alright. I'm gonna... Yeah, I'm sorry. I can't help you here, Geeky Rich. This is probably not the right place to do this too. To look for help too. So DS Tamilians, bro, can I sort it? Find a diff. Will this be correct? Try it out. Try it out. So 111 seconds, the minimum cost by comparing the direct adjacent costs. with the arrangement. Yeah. Yeah. It's all right. I think seconds you're sort of you're not, I think the main rule is don't put any code. Seconds you should be fine. Yeah, I have to remove this user, unfortunately. Yeah. Hint for question 3. Yeah, so question 3, I'm still working on it, so I don't know if how useful this hint is. But question 3 is basically, you know how to find. Okay, if I give you a path, right, like 2 1 2 1, okay, you should know how to find the longest special path from this 2 1 2 1, right? So if you know how to do that, then it's a matter of doing a backtracking. So this is a tree, so just do a backtracking. The way I'm doing it, right, at least, is I do a backtracking. I try all the possible combinations, all the possible paths from root to leaf, and then essentially, as I go along this one route from here to here to here to here, I keep track of what the best special paths are. Yeah, that's the basic logic I have. I hope that was helpful. I will be more helpful after I've successfully finished it myself, to be honest. And I will also be more helpful once once I'm able to solve it. Yeah, once the contest is over, I can go through the code. All right. Three is like Gandalf, man. You shall not pass. Yeah. Rate finance, that assumes the root will always be in the maximal path. No, it does not. So it needs to be. No, it doesn't assume the root will be in the maximal path. How do you select the root such that it's guaranteed to be part of? I don't quite get this. It doesn't. You don't ancestor to descendant node. No. So for instance, in this example, 014 starts from the root, but 25 here, 25 over here does not start from the root. Yeah, 25 here does not start from root. BFS from the same value nodes, it will take less time than making DFS call from a root node. It makes more. Are you sure? Yeah, it does sound like it makes a. Maybe you're right. I'm not sure. Yeah, maybe you're right. There's no way you can do DFS from every node. It will TLE. No, you don't need to do DFS from every node. So you do DFS starting from the base root node. But as you go down, you need to. It's not that simple where you assume the path starts from the first root. Yeah. So for instance, when you do this, so I'm still working on it. So take this with a grain of salt. But for instance, let's say this path, right? You're doing DFS and you go through here, but you don't. Let's say you're at this node here, right? You're at here, right? This is your current node, right? You don't assume that your DFS starts from here. You don't assume your DFS starts from here. You basically say, hey, what's the last node I saw? The last node I saw was the last node I saw, which still can be a special node, is this one. Yeah. So this is the one. So your special is only 6. It's not all the way here. So you have to do some bookkeeping. When you're doing the DFS, you have to do some bookkeeping to say what is the last node I saw, which is still eligible to be a special node. Yeah. So Krishna Jawa, question 2. I think a lot of people talked about it in chat already. There's only the hint is you can only you only have to do operation 1 at least one at most once. So you either do it 0 times or 1 time. So calculate this, if you don't sort it, what is the cost, and if you sort it, what's the cost. So that's the basic idea. But if you need more details, then we will talk about it after the contest ends, or somebody else in the chat can help you too. I just don't want to give like super obvious hints. Yeah. Huh. Hi medics. Will you take part in contest tomorrow? No. I won't. I only take part in one contest each weekend. Yeah. So Venkata Sai Lexman, welcome to channel. We don't post solutions here, so we don't post solutions. We don't ever post code. Just if you want to give hints, try to give like gentle hints. Don't be too obvious. But we definitely zero code policy. So there's absolutely zero code policy. If you really need a solution, if you want hints and you want help, ask in the chat. If you want just to see a solutions, wait until after the contest ends. We'll talk about it. We'll show the solutions after the contest ends. Yes. Oh, I feel like I'm having some difficulty with the bookkeeping on question 3. It's just a struggle. Yeah, it's a struggle. Okay. I have to change things up a little bit. Huh. If color in scene plus previous equals to Damn, I missed the last few contests. See you next week. Yeah, well, see you next week. Yeah, honestly, if you want, you can still jump in. I guess it's tricky. Yeah. Do you do a second one? Does it takes on brute force? It's not really brute force. It's just so Ashish Kumar Mohapatra. It's not quite brute force. It's just I won't call it brute force. I would call it the easiest solution, the most intuitive one. The most intuitive one would work. Yeah. Okay. Path lasts. Okay. Invalid syntax. Lasts equals to one positional argument. One missing position, right? 1, 2, 3, 4, 5, 6, 7, 8. Path last start. Longest. Oh, question 3 is taking so long. Damn it. Output limit exceeded. Okay. One two zero two. What is U? Okay. Let's try again. Okay. Let me read the chat. Sorry, I'm still I'm still working on question 3. Yeah. Hints for third one. Try fourth one. I'll try fourth one once I'm done with 3. So does brute force work in 3? Depends on what you mean by brute force. You will have to, at least the way I'm doing it, I'm gonna basically do a depth first search, but you cannot do a depth first search on every single node. You can only do one depth first search on the root node. So you need a way to figure out the special paths as you're going down. So that's actually a fairly standard question in its own right. Hopefully that's not too difficult. Okay. All right. I'm still debugging my solution for question 3. So, take that with a grain of salt. If I give you any hints, maybe it's wrong. Who knows? So, where's 0? So 1 parent 0, 2 parent 1, 5 parent 2. I'm basically doing a depth first search. Okay, I'm basically doing a depth first search. I think I got it. DFS on each node probably will not work. DFS on the root node, just the root node, and then you have to do some bookkeeping to make, find the special paths that don't start on the root node. If you do DFS on the root node, on every node, that's almost definitely not gonna work. I'm pretty sure that's not gonna work. equals to length minus max of my start last start length. Okay. Yeah, let me read the chat. Sorry, I'm still working on question 3. Yeah, my rank is gonna fall in this too. I'm doing DFS. Recursive function for every unique color, return distance. I love to see your solution in 30 or so minutes. Man, yeah, that's a lot of optimism from you. Hopefully I get it way before that because I have the code already. I just need to fix the bugs. Yeah, Q3 is waste of time. Q4 is pure math. Hey, dude. Okay, let me be honest with you. All of LeetCode, all your contests is a waste of time. So it is what it is. The fact that you're here, yeah. Like all of LeetCode is a waste of time. 0, 1, 2, 5. Three. Path is 2, 0 is 1. Brief. Yeah, there's something wrong with my backtracking algorithm. Otherwise, is working correctly. So last is this length 0. Oh, it's not working correctly. Damn it. 0. Yeah. Well, I have to go away from chat for a while. I need to focus up. I'm pretty confident. I really hope that I can able to squeeze in question 3 before the time limit. It'll be fabulous. So sorry if I can't reply to chat right now. I have to focus on. I have to focus. You have to focus on myself, essentially. Color equals pref equals to 1. Okay, color equals 2, pref equals to 1. 0, 1. Wait, this is not correct. Length of path. Okay. Okay, start. My start is length minus previous. So at node 2, start equals to 0. Okay, length is 5. Pref is 0. So pref plus 1. Oh no. Okay, I think I got it. Think I got it. 0. Okay. My length is 2. My depth is 2. Okay. My length is 3. My depth is 2. Okay. Cool. All right. Fingers crossed. Ah, damn it. Bug. 4, 3. 437 out of 675. Sorry if I'm so quiet. I'm trying to figure out. Yeah, nums is 113. Okay, I think I'm very close to victory. Last 6 more minutes. So I'm urgently trying to finish my work before then. My depth is wrong. Oh crap. Oh crap, I made a big mistake. Oh crap, I made a big mistake. Okay. Okay. Hope for the best. Output limit exceeded. Ah, crap. Yeah, sorry if I'm quiet. I'm in the last minute struggle. Oh, succeeded. Pass. Finally, you managed to pass question 3. Okay, all right. Oh my god. Finally managed to pass question 3. 4th was way better than 3. Oh, damn it. I should have looked at 4th. You got 4th, Suju Patil. Congrats. Okay, let me look at the chat. Question 3 is killing me. Yeah, question 3 is tough. At least I managed to do question 3. Okay, so contest is almost ending. I'm so glad I managed to get it in time. You managed to get 4? Yeah, I should have went for... Yeah, I'm going to take a look at 4. 4 is a very fun question. Really? I didn't get a chance to look at 4 at all. Well, congrats to those people who managed to do 4. It's 8 points, right? It's really good. It's better than doing 3. How are you storing your limit? Okay, so the contest is ending. It's like 20 more seconds. So we're about to go through all the answers. I'm gonna go start with question 3 first. Because that's the one that people want. Yeah. But before you guys go, while you guys are here, if once again, small selfish plug, which is if you like my content, make sure to like and subscribe. Just click the like button on this stream right now. It's gonna help me out a lot. Yeah, it's gonna boost. It's gonna make the algorithm think the video is good. If you drop a comment in the video, in the VOD once it's released this afternoon or this night, depending on where you are, then that will help me out a lot. Also, if you haven't already, please like and please subscribe to the channel. It will tell you when I'm streaming. I stream every weekend once. If there's bi-weekly, I'll do the bi-weekly. If there's no bi-weekly, I'll do the weekly. And let me see what else. Yeah, that's about it. Yeah, thanks everybody for supporting the channel. It means a lot to me. And if you have friends, tell them about it. I'm trying to grow this channel. I'm trying to hit 1,000 subscribers. I'm only at 825 right now. Hopefully, I can get 1,000 subscribers in about 6 months. Not that it matters a lot to me. It's not really my primary source of income, but it is kind of nice and validating to have more people watching. Okay. Yeah, please explain. I will explain third. I'm gonna get water. 4th was a Code Forces style. I hate Code Forces style. It's all mathematics disguised as programming. I'm gonna get water. I'll be right back. 30 seconds. Yeah, you gotta really hydrate, when you're when you're talking this much, you gotta really hydrate. Okay, I'm gonna do something a little bit different this week, which is I'm gonna start with the most interesting questions first instead of one starting from top, because I feel like that's what people want. I think that's what people want. So I'm gonna start with what I think is the most interesting question, which is question 3. But actually before that, before I forget, let me do the usual YouTube thing so I can bookmark this as the start of the video if I want. We are discussing solutions for LeetCode weekly contests Biweekly contest 148. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay updates on new videos. Remember, I stream once a week, every week. Bi-weekly contest if there is bi-weekly. If there's no bi-weekly, I'll stream the weekly. So once a week, come join us every week. Okay, alright. So I managed to do 3 questions. I snuck in the 3rd question in the nick of time. That's not, it's not ideal, but it's better than not doing it. So I would say that it's better than nothing. So let's go through the answers. I'm gonna start with question 3 this time because that's the one people want the most, and then I'll go back to question 1 and 2. Alright, so we'll start with question 3. The question 3 is longest special path. You are given an undirected tree rooted at node 0 with nodes from 0 to n-1 represented by 2D array edges. Indicates an edge between this and this. You're also given an array nums where nums represent the value. So basically it's a tree. It's a tree, and each of the tree has a value, has a nums. Okay? Has a nums. A special path is defined as a downward path from an ancestor to a descendant. Doesn't have to be from the root to the leaf. An ancestor to a descendant anywhere between the root and the leaf, such that the values of all nodes on the path are unique. Note that a path may start and end at the same node. So your job is to return an array of size 2. So return 2 answers. The first answer is the length of the longest special path. And the second answer is the minimum number of nodes in all possible longer special paths. So there are probably many longer special paths. You want to return the one with the least number of nodes. Okay, let's look at an example. This is not obvious question, so I want to go through an example. Okay, so first thing, you take these edges, you construct a graph. Okay, the graph looks like this. The nums are these values here. So each node has a num. Note that this picture does not show the num of each node. What it does, because we don't care about actual value of num, we just care that it's different. What it does is it color codes. So red, so 2 is red, like 1 is blue, and then 3 will be green. That's what it's doing in this picture. It's turning nums into colors. So it makes it easier to see. Okay? And then the way to read this is from this to this is actually this length 2. Okay? So each of the edges have weights. So your job is to find a path that is special and as long as possible, basically, right? So the special path is, let me see, the longest special path is, so 2 to 5, 2 to 5. Oh, sorry. So node 2 to node 5, 2 to 5. This is a special path because 2 and 5 have different colors. They have different num values. Okay, and its length is 6. The other special path is 0, 1, 4. So 0, 1, 4. Note that 0, 1, 4, all 3 nodes have different colors, so have different num values. That's what makes them special. And the length is 2 plus 4 is 6. Its length is 6. So we're not actually length is not actually the number of hops. Length is the sum of the weights on the edges in the path. Length is the sum of weights. These edges all have weights. They are the length. All right, it's not the number of hops. So this is a special path and this is a special path. Their length is both 6. This has 3 hops. This has 2 hops. So the answer that you're supposed to return is the longest special path is 6, and the smallest number of hops in all the longer special paths is 2, because this guy has, well, 1 hop but 2 nodes. So this one is of length 6 and it has 2 nodes in it. So the answer is 6, 2. Okay. Note a few things to clarify before we move on. This is not a special path, because special path has to be downwards from ancestor to descendant. This goes from descendant and then up and then go back down, so this is not a special path. Likewise, something like this would not be a special path because these two are the same color. Okay, so hopefully that was clear in the question. Okay, so how do you go about solving this problem? Well, one way is you do DFS on starting from every single node. So that would be a very bad idea, because that will run out of time very quickly, right? The next best idea is to do DFS starting from the root node and explore every single path down to from the root to every single leaf. So the catch is, the special paths do not always have to start from roots. So what you need to do is, when you add to the path, right? When you add to the path, you need to know what is the special path that ends in this. So for instance, I'm going from 0 to 1 to 2 to 5, right? When I reach 2, 0, 1, 2 is not a special path. When I reach 2, I have to know that the longest special path ending with 2 is from 1. I cannot do 0. It has to be from 1. Likewise, when I reach this 5 over here, I need to know that the longest special path for me is from here to here, from 2 and to 5. It cannot include 1. So I kind of have to, I kind of have to, what you might call it, I kind of have to remember what is the last node where there are no duplicates from that last node to me. Okay, so that's the basic idea. So basic idea number 1, DFS. Number 2, have some bookkeeping to keep track of the last scene of my color. You need to keep track. What's the last path I've seen that is of the same color as me? Okay, so with that out of the way, let me just explain my solution. So as you guys know, I hate edge lists. They are useless. I see an edge list, I turn it into a matrix, adjacency matrix. So first thing, I construct adjacency matrix. The next thing I do is I want to have a helper function. This one will help me do my DFS. And essentially what my DFS does is it does the following. I'm going to draw it out so it becomes easier. I'm going to keep track for every node I see. I'm going to keep track of what's the current path I'm on and what is the last scene of each color, as well as the last eligible start node. So for instance, this is a mouthful, but it becomes obvious once you see a picture. So at 0, 0 is nothing, so I don't care. At 1, my path is 0 to 1. Okay, and I'm going to put the colors. The last time I saw the color red was at 0. The last time I saw color blue was at 1. Okay? And so since I'm blue, there's no blue before me. I know my best path. My best path at this node 1 here, my longest path, is going to be my length, which is 2. And yeah, that's all, my length. So I know my longest path is going to be of length 2, and the number of hops is 0. So let me go down to here, 2. So at 2, my path is 0, 1, 2. So the last time I saw a red was at 0. The last time I saw a blue was at 1. Well, what's my color? I'm red. I'm red, right? So what that means is my longest path does not start at root. My longest path now start at the last red I saw plus 1. So my longest path start at 1 here, and the weight basically is 3, or the length is basically 3. Okay, so same thing when I get to 5. When I get to 5, the path is now 0, 1, 2, and 5. The last time I saw red was at 2, and the last time I saw blue was at 1. Now 5 is blue, and the last start I have, the last eligible start I have, is 1. So these indexes actually refer to the indexes of the path. It refers to indexes on the path. So last time I saw the last eligible start I have is 1, because I saw the last blue I saw was at node 1. I cannot use 1. I have to go to a next node in the path. So my next point in the path is 2. So I know my length is going to be 6. How do I know my length is 6? Basically, on the path, I keep track the length. So this is 0, 1 is going to be 2, 2 is going to be 5, 5 is going to be 5 plus 6, 11. So how do I, so if I know my last eligible start is at index 2, because my color is blue, I saw a blue at index 1, okay, means that the earliest start I can have is index 2. So at index 2, the length at index 2 from the root is 5. The length to me from the root is 11. So my best path is 11 minus 5 equals to 6. Yeah, so that's the basic idea. So basically what I do is I store the path that I have. I remember the last time I saw each color, and these are indexes on the path. I remember what is the last eligible start I have. This is also an index on the path. And then I will calculate my new best eligible start based on my color and the last time I saw this color. Okay, so the start is such that from start to me, there are only unique colors. And I will calculate my length by taking my current length, that's 11, minus the eligible start. Okay, so that's the basic idea. I hope that was not too wordy. So basically what I did is a DFS. As a DFS, and what I do is I keep track of current parent, I keep track of the path. So at every step of the DFS, I keep track of what is the path up to here. I keep track the last time I saw a specific color. What is the eligible start? Yeah, the idea is from start to where I am, I only have unique colors. I keep track of my length and depth. Okay, and the path includes both the colors as well as the length. So what I then do, let me just delete this real quick. What I then do at the start is I add to the path, and then I calculate what is my new start based on what the start is and whether I saw a node of the same color as me. If I saw a node of the same color as me after that at an index greater than start, I had to move start back. Okay, and then basically I do that, and this is the part that calculates my length. It's basically that you look at the path that I keep track and find out what's the length, my current length minus the length of start. Okay, and this is the part where I find out I compare my length to the best length I've seen so far, and I compare my depth to the best depth I've seen so far. So my depth, the number of hops I need for my best special path, is basically my current depth minus start plus 1, right? So start is the node such that from start to me, we only see unique colors. And then after I do that, I go to my kids. So this is DFS, and then I reset path and previous to my parent. I keep doing that until I reach the end. Then the longest here will be the answer. I hope that was helpful. Let me just read some comments. I can see the struggle. Yeah, the struggle is really a struggle. Limit of exploration for reach node. Yeah, so yeah, Nash. So the limit of exploration is based on, so what I did, I keep track of the path. I keep track of the last index on the path, such that from that last index to me, I only have unique nodes, only unique colors. I keep track of the last index on that path, such that from that last index to me, I only have unique colors. So DFS plus map, yeah. Why can any leaf node not be a root? The leaf nodes can be root, yeah. So for instance, how do I say? Yeah. So basically here updates the start, right? So if I saw somebody who has the same color as me just before, look at this number 3 here. This node 3. At node 3, my path is 0 and 1. My last scene, I saw blue at 1. That means that I'm screwed, basically. That means that my start will have to be previous plus 1, which is 2, which is me. Okay, so at node 3, my path is 0, 1, 3. This is blue, and this is red. The last blue I saw is at here. I'm also blue. So my start would be the last blue plus 1. So my start equals the previous plus 1. Yeah. So that means that my length is 0, because it's a length of 3, which is 7, minus the length of 3, which is 7, is 0. Yeah, and then the number of hops is 1. So this will work even when the special path is a leaf. So the longest special path ending in 3 is basically itself. It's just a leaf. I hope that was helpful. Any leaf node can be in root. Why not we reroute that? 4, 1, 2. No, not any leaf node can be a root. Any leaf node can be the start of a special path, but not every leaf node can be a root. Does that make sense? Yeah, it's a tree. The root is always 0. Yeah. Okay. Cool. I hope that was helpful. Let me go on to question 1. And I might come back to this if people have more questions. Let me go to question 1 and then I'll read the chat. Alright, question 1. Maximum difference between adjacent elements in a circular array. This should be pretty straightforward. You just do a for loop. You keep track. You have a variable called best, which is the biggest difference that you've seen so far. It starts at 0 because the absolute difference is at least 0. You just do a for loop and then you do yourself minus your adjacent, whatever number is either to the left or to the right, is up to you. Okay, the only catch is when you reach the end of the for loop, you need to loop backwards. So in Python, I can do 0 minus 1 will give me the index, give me the element all the way at the end. In other languages, you have to manually do this. So you're probably like this minus 1 and then do this, and then you have to do best equals to max of best and nums 0 minus nums length nums minus 1. So you have to take the absolute. You have to check one last time between the first and the last element. So other languages you manually do this. Python you don't have to. Minimum cost to make array identical. Okay, I think this one also most people got eventually. Yeah, the main trick here. So question 2, minimum cost to make arrays identical. You're given 2 integer arrays R and ber of length n and integer k. You can perform the following operations in R any number of times. Split R into any number of contiguous subarrays and rearrange them in any order. This costs k. Choose any element in R. Add or subtract a positive integer x to it. This costs x. So you can move either positively or negatively by any number, and the cost is x. So return the minimum total cost needed to make R equal to ber. Okay, so the first observation here is that when you split R into any number of contiguous subarrays and rearrange them in any order, how many subarrays do you want to split it to? The best way, the most powerful and most effective way to do it is just to split R into individual cells, and then you can rearrange these individual cells in any order. Okay, so this example splits R into -7 and 9,5. You don't have to do that. You just split them all in individual cells and rearrange them any way you want. So effectively, this is reorder with no limitations. It's just reorder the subarray. Right? It's just reorder in any way you want. Forget all these things about contiguous subarrays. They are, you can ignore them. Okay? So basically, this costs you k to reorder. Otherwise, you just have to compare the two arrays to see which one, how do you get one to the other. Well, how many times do you have to reorder? Well, maximum once, right? Because once you reorder, there's no reason to reorder it twice. Just reorder it to the final order that you want. And you want to make you want to make R equals to ber. Well, basically, which order do you want? Well, the way to minimize the difference between two arrays, you can mathematically prove this, is to sort both of them. The way to minimize the difference, this basically calculates the absolute difference between the two arrays. And then the best way to do this is to sort both of them. Right? And then calculate the difference. So essentially there are two possible options. First option is you don't do any k, you don't do any sorting, you calculate what's the absolute difference between two arrays. That will be your cost. Second option is you sort both of them. Why do I sort ber? Because I can sort R to anything I want, right? I can sort R. I technically cannot sort Burr, but let's say Burr is 7 minus 2, 5, right? I can sort R such that the smallest number is here, a second smallest number here, third smallest number is here. So I can always sort R to match the sort of order of Burr. And to make things simple, I'm going to sort both of them. Okay, so I sort both of them, and I take the absolute difference, and I add k. So essentially, either I don't sort, I take the absolute difference, or I sort, I take that absolute difference, which should usually be better, but I have to add additional k cost. I find out the minimum between the two, and that's the answer. Okay, let me read the chat. Was able to solve one and the others were difficult. Yeah, the others are, so Danny Staples, good job on solving one. First of all, I don't let anybody take that away from you, right? Solving one question in a competitive situation is pretty good already. So work on the daily problems, do your best, and eventually you get better. It's all about practice. Rate finance, why can we not rerule? Okay. Yeah, so question 3, undirected. Yeah, undirected confused a lot of people. Well, the reason why they said it was undirected was just to make it trickier for you to figure out the tree. If they want to give you an easier problem, they don't have to give you this stupid edge list. They can always give us as tree. Just give us a tree data structure. Yeah, got stuck at fixing one edge case in question 3. I got stuck fixing one edge case in question 3 also. So it was definitely very annoying. Okay, let's look at question 4. It looks like many of you it seems like many of you got question 4. So apparently it's easy. Right? Just let me know in the chat who got question 4. I think Sujit and who's the other one? Someone else. I think Sujit and one other person got question 4. Alright. Question 4. Manhattan distances of all arrangements of pieces. You're given 3 integers m, n, and k. There's a rectangular grid of size mn with k identical pieces. Return the sum of Manhattan distances between every piece over all valid arrangements of pieces. A valid arrangement is a placement of k pieces on the grid with at most 1 piece per cell. This seems like a math problem. Manhattan distances. Okay. Okay, so let's say k equals to 2. So Manhattan distance is 1, 2, 3, and this is 4. Manhattan distance is 2 and 2. Okay. Okay, so you when k is 2, you just take pairs of Manhattan distance. Okay, when k is 3, the first one has Manhattan distance 1 plus 1 plus 2. Okay, so it's basically 1 plus 1 plus 2. Oh, smiley face equals to 4. This is 1 plus 2 plus 3 equals to 6. Interesting. Yeah, I don't know. No obvious solution jumps out at me. No obvious solution jumps out at me. I guess if I had to guess, I'll probably try to solve for k equals to 2 first. For k equals to 2 first. For this square, I have to calculate the Manhattan distance to all the other squares. Okay, that can be calculated because it's just if you're in the same row, then your Manhattan distance is just your column minus 1, and then you're in a different column. Yeah, then you can multiply. Yeah. Okay, so it's basically okay. So to calculate the Manhattan distance for this is, let's say you're here, you just take 1, 2, 1 plus 2 is 3, and you multiply that by the number of rows. So it's 2 rows equals to 6. Because you have to go down. Oh, plus, this is the number of times you have to go sideways. So if you're on the same row, the number of times you have to go sideways is 1 plus 1 plus 2, which is 3. And then there are 2 rows, so you have to go sideways for everybody on this row, and to go sideways for everybody on this row. This is 6 times. You have 6 times sideways, plus how many times is it vertically? So 1 time times 3. So for Manhattan distance for P is going to be 9. Okay, with 2P is going to be 9. I can do this for all positions in P. For instance, if P is here, then the number of times you go sideways is 1 plus 2. So 2 times 2 equals to 4. Yeah, that's how I'm thinking about it. But what if the k equals to so k equals 2 is easy. What if k equals to 3? What if k equals to 3? Yeah. So k equals to 3, I'm not sure. I wonder if Sujit has a plan for k equals to 3. What if k equals to 3? K equals to 3, so you have to go to each of the squares. Plus the other place P is for each of the squares. Wait, isn't that just double? It's not quite double. Yeah, I think there's some math problem here. I'm not understanding. So P1, let's say P2 is here and P3 is here. So P3 can be any of these squares except P2. Yeah. So I can get all the distances from P1 to P2 quite easily. If I add P3, you have to think about it a little bit. I'm not sure what there's some mathematics behind it. So I think the part that I got so far is that if k equals to 2, there's P1 and P each location of P1, you can calculate how many horizontal moves you get based on which column you're in, and how many vertical moves you need based on which row you're in. So for instance, let's say P1 is here, you have to cover all the possible columns, you need to move left one time, move right one time, so that's 2, and you can do this for every row. And you have 2 rows, is 2 times 2 is 4. If the grid is like this, then at this square, this is going to be 1, 2, 3, 4. 4 times 4 is 4 times 2 is 8. Yeah. Okay. But I don't know what happens when k equals to 3. So k equals to 2 is easy. K equals to 3. Yeah, k equals to 3, I don't know. So k equals 3, is it just... Oh, wait a second. So k equals to 3 is equals to k equals to 2 times 2 minus something. Yeah, times 2 minus something. Yeah, I think it's some math there. I think there's some math. So basically, you need to find out how much one thing costs, and then do some math to find out. You need to solve the problem for k equals 2 first, and then use that to solve k equals 3, k equals 4, k equals 5. Yeah. So k equals to 3 is basically k equals to 2 times 2 minus something. I don't know what that something is. Yeah. I gotta yeah, gotta figure it out. Okay, let me see. Oh, formula for k equals just the number of valid placement changes. Yeah, number of the oh, okay, I see. Yeah, I see. I get it. I have to figure it out. It takes some thinking. It's like a math problem. Yeah. Thanks, Sujit Patel. So Nash, Alex in third. Why don't we store the visitor node in a map along with the distance moves up to them? And when the same color is node, just remove the distance of the same color from current distance. Let me see if I... So you want to store the visited nodes in a map? Yeah. So you can. So the part I'm a little bit nervous about is when you say when the same color node is reached, then remove the distance of the same color from current distance. You can, but there's a catch. I'll show you. There's a case you need to be careful of. So let's say it's red, blue. I'm visualizing this as a single path, right? Okay. If I understand you correctly, you visit a node in a map along with the distance up to them and what color node is reached. Just remove the distance of the same color from the current distance. Yeah, you have to... So that's the basic idea, yes, but you have to take care of one extra special case. So for instance, let's say your path you've seen so far is red, blue, blue, green, right? When you're at blue, the last seen blue you have is here. So you're like, oh, well, sucks to be me. My length is now 0, right? Now when you're at green, your last seen green... Or let me change this something better yet. To red, my last seen red is here. So you might say, hey, I can take the path, just minus this red here. No, you can't do that. Because your path doesn't contain 2 reds, but it contains 2 blues. So it contains 2 blues. So you need to keep track of the last valid start. So that's why I have this start variable here. I did the exact same thing as you, and then I ran to a bug. I ran to one of the test cases failed. And I realized that it was something like blue, blue, red. And when I reached this red, I said, well, I've never seen red before. I bet I can get a special path starting all the way from root. That's not true. Because somewhere along the way between me and root, there's a pair of nodes that are the same color. So I don't just have to check that I don't have to check my own color. I don't have to check I don't just have to check the last occurrence of my own color. I need to make sure that I need to have a special like start variable that keeps track of the last time there were no duplicates. I hope that answers your question. Just erase the map? Yeah, okay. Yes, just erase the map. Okay, let me try to answer that question. I think there's another problem with just erase the map, which is that is a very expensive operation. Remember? Okay? So when you're here and you want to just erase the map, you have to find all these guys. You have to find all these guys and erase them. And you're going to keep all these guys. So you want to erase the map. I mean, it's possible. I guess it's possible. Actually, I think you're right. You can just erase the map. Right? If you use a deck, I use a list. So, yeah, it's not so easy to erase up to this point. I wanted it to be a little bit fast. I guess you can erase it. That's true. Yeah. Yeah. You just make sure this is not an ON operation. If this is ON, based on the length of the path, then it will be very slow. You need a fast way to get rid of all these guys very quickly. I guess you can do it. mp.clear, you cannot clear. You cannot clear because you need to keep these guys. You found a blue, right? You need to keep everybody after the previous blue. You cannot clear the whole path. You need to keep these guys. You have to delete the ones before the previous blue. So you need a data structure that will efficiently delete the start of the whatever this is. So you use I don't think you can use array or vector, but you use like a two-sided list or something, then a linked list or something, two-sided array or something, you can do it. Medics, I got the logic, find the minimum hops and longest distance, but the code to build the tree is not happening. Well, the code to build the tree is actually easier because it's just a DFS. It's just a DFS. The logic to find the minimum hops and longest distance is actually a little bit harder. So, yeah, building the adjacency list from the undirected edge list is definitely the hardest part. Yeah, so I will tell you, you know what's the secret? You can just write this and keep it in a text file somewhere. And when you need it, you copy paste. You're not stealing, you're not plagiarizing, it's your own code. So just keep very common operations like these. Let me see if I have GitHub. I actually have a GitHub account that does this. Yeah, in fact, I can share my GitHub account that does this. In fact, I can share yeah, so I have like heap. These are this is my own heap because the Python heap is very stupid. I have like numbers. I have, I have graphs. These are all my like sort of cheat code. If I need it, I'll copy paste, and I'm not cheating because it's my own code. And two, this is very standard code that I write. That if it's very very standard code. It's like super standard code. There's no thinking behind it, so I'm not actually doing anything wrong. So I pre-write all these things. I just copy paste. I modify a little bit the variable names and all that. So that makes it a little bit faster if it helps. I don't often use these, even though I write a lot of them. But it's up to you. Yeah. KMP to store color. Oh yeah, you don't need KMP. The problem with KMP is that it doesn't know ancestors and descendants, so it's tricky. All right, so BTS Army. Okay, BTS Army said something really interesting. Count pure factorials and a modular inverse. Squared different for XY coordinates. Okay, representing total distance multiplied by the number of valid arrangements. Oh, interesting. Oh, interesting. Yeah, I see. I see where you're going with this. So basically, you calculate the pairs and then you multiply by number of modules. Yeah. Okay. Yeah. No, you're right. I was wrong about this. Yeah. So basically, you calculate the pairs. The pairs is the easy part, and then yeah. Binomial coefficient. I guess. Yeah, this one I don't quite understand. I guess my math is not that strong. This is combinatrix problem. But you just find like left plus right times column times number of rows. I think it works too. Okay, and then you multiply it by number of valid arrangements. Oh, okay. You know what? Yeah, I think maybe question 4 is not that hard. Damn it. I should have done question 4. I missed out on 8 points. But it's alright. It is what it is. Okay, so let me see. Maddox. Returning the adjacency lists from the Nash. I'll be crazy if I just thought of using KMP to store color. Yeah, KMP I don't think works because KMP doesn't know what is an ancestor and what's a descendant. That is actually a much harder problem if it's not a tree. Then yeah, you might actually need KMP. Even like so it's actually not even KMP because KMP is shortest path between any two pairs of nodes. You are looking for longest path with unique colors. So I don't know whether KMP will work. So Maddox, I just returned a hash map with keys as yes. So I do the same thing as you. I need to relearn heap and others and maybe create a repo like yours. Yeah. So it's useful. It's not like super useful. To be honest, the function I use the most is this one, edge list to adjacency matrix, because I hate the stupid edge list so much. Nobody uses. There's no reason to use an edge list in real life, right? There's no reason to use it ever. There's no reason to ever use an edge list in real life. I can't think of even one time. Real question, BTS Army, thumbs up or thumbs down? Oh my god, I'm not gonna get involved in this BTS war. I assume that BTS Army is a huge fan of BTS. I'm not really a K-pop person, so I really don't know much about them. I heard like 2 songs, some of their Korean songs. I don't understand Korean. Yeah, I don't know. Maybe if you know Korean or you know a lot about K-pop, then you'll love them. They are very popular. Apparently, the amount of money that BTS makes is more than the GDP of some small countries. So, yeah, BTS actually contribute a sizable part of South Korea's GDP. Okay, so I think that's the end of the stream. Yeah, I'm a little bit happy that I got 3 questions instead of 2. So it's a little bit of an upgrade. I managed to get the last question in literally 2 minutes before closing time. So, whew. But I'm sad I didn't manage to try the last question. Question 4 probably would have been easier than question 3. I think, at the end of the day, more programming, more practice. More programming, more practice. Oh my god, please don't turn this into a K-pop chat. Yeah. Yeah. I'll make this a K-pop chat, I don't care. K-pop and LeetCode is quite an unusual combination of things. Yeah. Plus, I think a lot of my viewership is from India, so I don't know if BTS is that big in India. Maybe it is. I have no idea. Okay. Let me just check what's my rating. 1,000. Okay, it's not that bad. 1,000 is still, it's not good, but it's not that bad. I'll take it. Yeah, maybe next time I'll look at all 4 questions and try to solve them first. Okay, all right. I think this is sadly, it's very big in India. My mom is a BTS fan. Really? That is shocking to me. Well, it's very big in America too. It's people like what they like. You hate it? Yeah. Well, I don't play music while I'm running my channel. Maybe I should play some music next time. But it's going to be classical, so definitely no BTS. Yeah, if people like music, let me know. I could play some music while the live stream is going on. I see a lot of streamers do that. Okay, so I think that's the end of our live stream for today. Thanks to everybody for sticking around. Once again, if you haven't subscribed yet, this will be a good time to do it. Smash that like button on this live stream. It's just one click away. Tell your friends if you have friends who are interested in this kind of stuff. Whenever I go check their code, 20% AI generated. Yeah, you know what? It is. Thanks for explaining your approaches. Yeah, you're welcome. I think that's my favorite part, is explaining my thought processes. Yeah, extra fingers faster? Maybe. Let's see how it goes. All right, thanks a lot. I got to go get lunch, and I think some of you guys probably heading to bed. So good night or good afternoon, wherever you are. See you all next week.